Students, this video is for Tuesday, December 3rd, when we get back from Thanksgiving break. We're going to learn about point-slope form, which is a new form. Right now, we know about slope-intercept form, which is y equals mx plus b. And here in a couple of weeks, we're going to learn about standard form, which is ax plus by equals c. But today, we're going to focus on point-slope form. Here is what point-slope form looks like. It's y minus y sub 1, which this is just going to be a number, equals m times x minus x sub 1, and this is also just going to be a number. Slope is also going to be a number, so it'll be y minus a number equals a number times x minus a number. To do point-slope form, you plug in your x1 and your y1, so you're going to be given a point, and you're going to plug those 2 points in, you're going to plug your slope in, and then you'll end up distributing this. You'll do a double rainbow on your m, add or subtract this number away, so you'll move this to the other side, and then you'll end up with something in slope-intercept form. Okay, and that may not all mean a ton right now, but as we start to work the problems, you'll get a better idea of it. Down here, we're going to cross out this slope-intercept form. This is another way of doing the point-slope method, but it's kind of confusing to try to learn two different ways here on the first day, so we're going to focus mainly on just this point-slope form. Alright, when we go to do these problems, we have our m, and we have a point. This point is an x and a y. So we go to set up our point-slope form. It looks like this: y minus y1 equals m times x minus x1, where this is our x1 and this is our y1. It's just the points that we were given. Okay, so the next thing we're going to do is plug in all the stuff we were given. So that 3 is going to go there. This negative 3 is going to go here. And this 1 right here is going to go all the way over to right there, because that's our y1. So it'll look like this: y minus 1 equals 3 times x minus a negative 3. Alright, the first thing we'll do is, if we ever see any back-to-back negatives here, we'll change them into pluses. And you learned that back in middle school. Our goal is to solve this for y. So eventually we're going to have to move that 1 away, but before we do that, we're going to double rainbow 3 times both of those. So y minus 1 equals 3 times x is 3x, and 3 times a positive 3 is a positive 9. And then our last step is just to plus 1 to both sides. And so this is y equals, those cancel, nothing to do with the 3x. 9 plus 1 is 10, and that is our answer, 3x plus 10. Okay. Once you get past this first step up here of plugging it in, everything else is pretty easy after that. Okay, let's skip down here and do one with a fraction. So we have y minus y1 equals m times x minus x1, where this is our m, our x1, and our y1. So y minus our y1 this time is 0 equals, we have a fraction this time for our slope, and then x minus a negative 2. And this happens a lot where you get the back-to-back minuses. So we're going to change that into a plus now. We're going to distribute that. We'll go ahead and box that, so we'll bring that down. We could actually go ahead and do y minus 0 and just get rid of that 0. Negative 1/2 times x is negative half x, and negative 1/2 times positive 2 is negative 1. There's no 0 to move over, so this one is actually done. Okay, this is our slope, this is our b. Okay, so another thing it helps us do, it helps us find the y-intercept. This has a y-intercept of negative 1, so if we were to put this on a graph, it would cross at negative 1. This one up here would cross at 10. Okay, now we'll do one where we have a slope of 0 and see how that affects it. Here's our x1 and our y1. So we have y minus y1 equals m times x minus x1. 0 goes there. 5 goes over here. Negative 3 goes there. So we have y minus 5 equals 0 times x minus a negative 3. So again, this changes to positive. We'll double rainbow the 0. So that stays y minus 5. 0 times x is 0x. 0 times 3 is 0. Get rid of this by plus and 5 to both sides. That cancels. y equals 0x. 0 plus 5 is 5. And then this would just get written as y equals 5. The 0x would go away. The last one that's kind of weird and difficult to look at is this one where it's undefined. And we know that the undefined ones are weird and kind of unusual problems. We could go ahead and label this x1, y1. It doesn't make much sense to plug this in because we can't plug in undefined in for our slope and be able to get anything to happen on that. Okay, so what we have to remember is that anytime that it's undefined, it's at a vertical line like that. If you remember back to slope face, which we've looked at several times, anything that is unusual, undefined like this, starts out as x equals. And what does x equal? 1. So this is just a vertical line of x equals 1. Nothing else we can do on that. Okay? Let's do one more here. This is m, this is our x, and this is our y. And we'll y minus y1 equals m times x minus x1. We'll plug everything in. Y minus 0 equals 1/3 times x minus 0. This right here is known as point slope form. So if anyone ever asks you to leave it in point slope form, you would leave it in this step right here with the parentheses, with the subtraction and everything. Usually we're going to go one step further and put this into slope-intercept form. So if we distribute, this will be y. We'll go ahead and get rid of the 0. 1/3 times x is 1/3 x. 1/3 times 0 is nothing. And this one is just 1/3 x. But just know if you're ever asked to leave it in point slope form, it's going to look like that with the parentheses. And the next thing is a real-world problem here. We have a repairman who charges $25 per hour plus a service fee. And then a bill for this, for him, 3 hours is $105. What are the independent and dependent variables? So we know that we have hours and we have money. Okay? Our money always depends on our hours worked, or the hours we choose this guy to work. Okay? We know that for 3 hours it's $105. And we know that it's going up $25 per hour. So we know that this next one is going to be up $25, which will be $130. And the same thing, the next one is up $25, so $155. Likewise, if we were to go down before 105, that was $25 before that, which would have been 80. That was $25 before it, which would have been 55. And that was $25 before it, which would have been 30. I'm going to hold off on my equation and go down here and go ahead and plot this. This is my hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hours. This is my money. And I'm going to go by 25s. 25, 50, 75, 100, 125, 150, 175, 200. I'll stop there for now. At 1 hour worked, at 0 hours, it was $30, which would be about right there. At 1 hour worked, it was $55, which would be about right there. At 2 hours, it was $80, which would be right there. At 3 hours, it was $105. And so you can kind of start to see that this would be the graph. Our question says identify a point. Well, the point we know is that 3 goes with 105. Our m, we know that it's $25 per person. And it wants us to write an equation in point slope form. So this would be our x1 and our y1. So this would look like this. Y minus y1 equals m times x minus x1. So y minus our y is 105. Our m is 25. And our x is 3. So double rainbow. Y minus 105 equals 25 times x minus 25 times 3, 75. Add 105 to both sides to finish this off. Y equals 25x. Negative 75 plus 105 is 30. And so this is the equation in slope-intercept form. Y equals 25x plus 30. And if you look back at the table we did just a minute ago, you'll find out that this 30 is what it is if you do 0 hours. So if you call the repairman out and don't actually use him, it costs $30. It's the initial fee. And that's what the next one asks us. What is B? B is 30. And this is the initial fee of $30. And he charges that just to come out and look at your job to see if he wants to do it or not. How much would they charge for a 7-hour? So that would be 25 times 7 hours plus the $30 fee. And that comes out to be 205. Let me double check that in my calculator real quick. 25 times 7 plus 30. Yeah, 205. A reasonable domain and range. So the reasonable number of hours worked. He could work 0 hours. And domain is X. We just kind of have to pick a number here. What would be a reasonable amount of hours? And it kind of would depend on what kind of repairman he was. Let's just say that 10 hours. Okay. And if we do that, then a reasonable range, or the money charged, would be from 0 to Y. If I plug in 10, 25 times 10 plus 30 goes up to $280. Okay, so if you estimate 0 to 10 hours for your job, you estimate 0 to $280 for your job. Last one says, suppose you have $140 to spend. How long could you do a service call for? Well, we know it's $25 per hour plus a $30 fee equals $140. So this is just an equation that we solved back in the first semester, or the first 6 weeks. Subtract 30 from both sides, because that's your fee. Once you take out the fee, you have $110 left over, and you're going to divide that by the 25 he charges per hour. So 110 divided by 25 is 4.4 hours. So if he only charges in whole hour increments, you could only do 4 hours. If he lets you do partial hours, you could do up close to 4.5 hours. Just couldn't get quite to 4.5 though.